of the video from question number 39. Part 1 was question number 1 to 30. Part 2 was from 31 to 38. Now from question number 39 onwards, we are doing part 3. So this is 10 marks question without GDC. Sketch the graph for y equals to pi sin x minus x between minus 3 to 3. Label both the axes and indicate clearly the approximate positions of x-intercepts, local maximum and minimum points. So what am I going to do? This is with GDC. I'm going to draw with the help of a GDC. I draw it out over here. Then approximate shape of the curve will be in this way. This is between -3 and -2, and this is between 2 and 3, and 1 over here, x-axis, y-axis, and -1 over here, -2, +1 and +2. Now we can see that this point is -2.3, 0, and over here it is 1.25, 1.73. Check with the calculator, you are going to get the same answer, 2.3, 0, and finally the minimum point is -1.25, -1.73. So we have done all the x-intercepts, we have done the maximum point and the minimum point. Find the solution of this equation. By the calculator, you should be able to get that value, x equals to 2.31. Find the indefinite integral pi sin x minus x, and hence otherwise calculate the area of the region by the graph x-axis and line x equals to 1. So for part C, integral pi sin x minus x dx, which will be minus pi cos x minus x square upon 2 plus c. Now he is asking us to find the area, which is 0 to 1 pi sin x minus x dx, which is going to be 0.944. Question number 40. Sketch the graph for y equal to x square cos x between 0 to 2. Clearly making clear approximate positions of positive x-intercept, maximum and endpoint. Find the approximate coordinates of the positive x-intercept, the maximum point and the endpoints. So once again, what am I going to do? I am going to draw the graph for this. It looks like this. Then this point is 1.1, 0.55, and this is 1.51, 0, and the shaded region is, this is going to be the shaded region R. 0, x-axis and y-axis. Don't forget to write this one. Now for the part 2. Approximate coordinates of the positive x-intercepts and y-intercepts. So what does it becomes? 1.57, 0, and so positive x-intercept. Positive x-intercept is 1.57, 0, and maximum point is 1.1, 0.55. Endpoints will be 0, 0, and 2, minus 1.66. Next, part B, find the exact value of x-intercept. So for part B, x square cos x equals to 0. So as x cannot be equals to 0, so cos x equals to 0. It implies x equals to pi by 2. C part, region R is the first quadrant enclosed by the graph and the x-axis. Shade that. We have already done that one part. Write down the integral for the area of the shaded region. So for that it will be 0 to pi by 2 x square cos x dx. Now, because it is with GDC, you can directly use this GDC and get that answer as 0.467. That's going to be the answer. Question number 41. Radians are to be used throughout this question. Draw the graph for y equals to pi plus x cos x. Make clear the integer values of x and y on each axis. Approximate positions of x-intercepts and turning points. Without the use of calculator, show that pi is a solution for this equation. So first of all, I am drawing the graph over there. X-axis and y-axis. Then it becomes in this way. This value is 3, 2 and 1, 1 and 2 and 3 and 4, 5 over here. Now this is your maximum point. Now, without the use of the calculator, show that pi is the solution for this one. So for that, what am I going to use that one? For part B, substitute pi plus cos pi, pi cos pi. So which is pi plus pi times of -1, which is going to be 0. So therefore, it is a solution. Now for part C, find another solution for this, giving your answer in 6 significant figures. Use the calculator, you should be getting 3.696, 6967229, so on. So it will become 3.69672. Part D, let R be the region enclosed by this one. Shade the region R in your diagram. So this is the region. Now part E, 0 to pi, pi plus x cos x dx, x cos x dx. Simplify that or use the calculator, you will be getting it out 60. That's going to be the answer. Question number 42. The diagram below shows the part of the graph f of x equals to x cube plus 2x square plus 15x. The graph intersects x-axis at these points. There is a minimum point at P and a maximum point at Q. The function may also be written in the form of x times x minus a, x minus b. Write down the value of a and b. So a is your -3 and 5. So a is -3 and b is 5. Now find the exact values of f prime x equals to 0. So first of all, f prime x. So I'm going to find it out. F prime x. F prime x will be equals to 3x square minus 3x square plus 4x plus 15. So -3x square plus 4x plus 15 equals to 0, which gives me x equals to, because this is by GDC, directly you can get that value, x equals to -5/3 and x equals to 3. Find the function, find the value of the function at Q. So for part 3, B part 2, x equals to 3. So f of 3 will be equals to -27 plus 18 plus 45, which is going to be 36. C, find the equation of a tangent at f equals to 0. So for C part 1, at x equals to 0, f prime of 0 equals to 15. So gradient of the line will be equals to 15. So but it is passing through 0 comma 0, so the equation will be y equals to 15x. This tangent cuts the graph at f at r. Find the x coordinate of r. So for part 2, minus x cube plus 2x square plus 15x equals to 15x. So it becomes minus x cube plus 2x square equals to 0. So negative x square times x minus 2 equals to 0. So x equals to 2. Then finally find the area of the shaded region. Use the GDC to get the area of the shaded region as 150. Question number 43. The following diagram shows the part of the graph f of x equals to sin x whole square cos x, x is in radians. The point A is the maximum point, point B lies on the x-axis. Find f prime x. F prime x, when I'm trying to find it out, so there are two, what is this, chain rule, product rule. So I keep cos x as it is, times sin x whole square derivative is 2 sin x, again sin x derivative is cos x. Next time minus sin x whole square as it is, kept as it is, then cos x derivative is minus sin x. When I try to simplify this, it becomes sin x common, 2 cos square x minus sin square x. That's going to be the answer for the first part. Hence show that at a x equals to 1 upon 3. So for part 2, f prime x should be equals to 0. So what does that become? Sin x times 2 cos square x minus sin square x equals to 0. So sin x times 2 cos square x. Sin square x is 1 minus cos square x. 1 minus of minus 1 plus cos square x equals to 0. So we get 3 cos square x minus 1 equals to 0. So cos square x equals to 1 upon 3. Cos x equals to square root of 1 upon 3. Because f of x is greater than 0, so I use only positive 1 upon 3, not negative 1 upon 3. Next, find integral of f of x. Find the exact value of x coordinate of b. X coordinate of b for part b, it will be x equals to pi by 2. From the graphing calculator, you can do that x equals to pi by 2. Then c part. Integral of sin x whole square times cos x dx. This is sin x whole to the power of 3 divided by 3 plus c. What is the formula I have used? Any function to the power of n times that function's derivative dx will become that function to the power of n plus 1 upon n plus 1 plus c. Now for part 2 area, apply the limit 0 to pi by 2. Sin x whole square cos x dx will become 1 upon 3 sin x whole cube by 3 from 0 to pi by 2. So it's going to be 1 upon 3. That is part C. Now part D, show that f double prime x is equal to, and hence show that C at the point C cos x equals to root 3. So first of all, we got f prime x. What was that? 2 sin x cos square x minus sin cube x. Then f double prime x will become 2 cos x cos square x plus 2 sin x, which is minus 2 cos x sin x minus 3 sin square x cos x. What is all this? This is uv. So what am I going to do that? This is u and this is u prime and this is v. This is v prime and this is u, and its derivative is this one by chain rule. uv prime plus vu prime. Then further simplify that, it becomes 2 cos cube x minus 4 cos x sin square x minus 3 sin square x cos x. So it becomes 2 cos cube x minus 7 cos x sin square x. That should be equals to 2 cos cube x minus 7 cos x. Sin square x is again nothing but what? 1 minus cos square x. So it will become 9 cos cube x minus 7 cos x. Now at C, f prime double prime x should be equals to 0. 9 cos cube x minus 7 cos x should be equals to 0. So take cos x common. 9 cos square x minus 7 equals to 0. So we get x equals to pi by 2, or cos square x equals to 7 by 9. X equals to pi by 2 is rejected. Cos square x equals to 7 by 9. Cos x equals to positive square root 7 upon 3. Question number 44. Show that integral of e power minus kx dx equals to this much. So part A, it becomes 0 to 1 integral of minus kx dx equals to e power minus kx minus upon k from 0 to 1. So it becomes minus 1 upon k outside, e power minus k minus e power 0. So it becomes minus 1 upon k, e power minus k minus 1. So take that minus inside, so 1 minus e power minus k. Let k equal to 0.5, sketch the graph. So for part B, the graph should be approximately in this way. This point is 0, 1, and this is going to be the area of the shaded region, x-axis and y-axis. Shade the region enclosed by and x equals to 1. Find the area of this region. So is it by GDC? If at all I use the GDC, the area will be equals to 0.787. Then part C, find dy by dx. Find dy by dx. There we should be able to get that answer. So what that answer is, so part C, dy by dx equals to minus k e power minus kx. Then find the value of k given that at the point p 1, 0.8 lies on the graph. So x equals to 1, y equals to 0.8. So 0.8 equals to e power minus k. So ln 0.8 equals to ln e power minus k. So k equal to 0.223. Then part 3, find the gradient of the tangent at P. So at x equals to 1, dy by dx equals to 0.8 ln 0.8. So that value is going to be nothing but what? Minus 0.178. Now coming to question number 45. Let f of x equals to minus 3 upon 4 x square plus x plus 4. Find the equation of the normal to the curve at 2, 3. So first I am finding it out f prime x, which is negative 3 by 2x plus 1. So f prime of 2 should be equals to negative 2. So the slope of the normal will become 1 upon 2. So what will be the equation? Y minus y1 equals to m times x minus x1. So which becomes y equals to 1 upon 2x plus 2. Then the normal intersects the curve at 2, 3. Find the other point. So for part 2, minus 3 upon 4x square plus x plus 4 should be equals to 1 upon 2x plus 2. So from here I get a quadratic equals to 0. So x equals to negative 4 upon 3, which is minus 1.33. Let R be the region. So find an expression for R and hence evaluate this. So it is minus 1 to 2 minus 3 upon 4x square plus x plus 4 dx, which is going to be minus 1 upon 4x cube plus 1 upon 2x square plus 4x from minus 1 to 2. Simplify that, you should be able to get 45 upon 4 or 11.25. Question number 46. The diagram below shows a sketch of the graph of a function y equals to sin e power x, where x lies between negative 1 and 2, x is in radians. The graph cuts the y-axis at A and x-axis at C and D. The maximum point is at B. Find the coordinates of A. At A, x equals to 0. So y equals to sin e power 0, which is equals to sin 1. So which is equals to 0.841. So the coordinates will be 0, 0.841. Part B, the coordinates of C can be written in the form of ln k, 0. Find the exact value of k. So sin e power x equals to 0. So e power x equals to pi. So x equals to ln pi. So k equals to pi. Write down the y coordinate of B. Maximum value of sine will be equals to 1. Dy by dx, and show that at B x equals to ln pi by 2. So dy by dx will be equals to e power x cos e power x. So dy by dx should be equals to 0 at maximum point. So e power x cos e power x equals to 0. So e power x equals to 0, which is not possible. Cos e power x equals to 0. So e power x should be equals to pi by 2. So x equals to ln pi by 2. That's going to be the case. So that completes part 3 of the video. See you in the part 4. Bye.